The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you very much, Anna. A very good day to everyone, and thanks a lot for joining this webinar. This is the 2023 tinyML Challenge finale. My name is Thomas Pascal from ITU, and I would like to welcome you once again. In today's session, we are going to see quite interesting solutions that are part of the 2023 tinyML Challenge. We had 3 problem statements: smart weather station based on tinyML, crop disease detection or plant disease detection, as well as wildlife monitoring using tinyML solutions. We have received quite a number of submissions, and we look forward to see what the top solutions have in for us. We are going to see 5 presentations from teams representing the solutions from the challenge that we have received this year. And of course, we have an update on the smart weather station problem statement. So be on the look for that. And of course, for more, the solutions itself, the open source code reports, as well as the demos and applications that you can see in this webinar. Quite incredible webinar to say. So without further ado, I would like to request our speakers. We have Evgen Gusev, who is the chairman of the board for the tinyML Foundation, to give some few opening remarks. So thank you so much, Evgen, for waking up very much early in California. I know, thank you for supporting our activities, and good morning to you.
Yeah, I'm going to be very brief. I think we're really excited about this next set of tinyML challenges done jointly with ITU. I think this collaboration is always very productive because tinyML Foundation, we develop our community and partners develop a lot of technologies in the energy efficient ML space, and I think applications for good are important, and I think it's really exciting to see these 3 very diverse areas today, and we are looking forward to this. And we would like to thank ITU and Thomas and everyone involved for organizing this, and also for all the participants for participating and submitting your interesting projects. So really looking forward to this. Thank you.
Thank you so much. I would also like to welcome Jonah, who is from CISEM, one of the organizers of the Smart Weather Station. So he has some announcements and of course some few opening remarks. So Jonah, good afternoon.
So hello everyone. Thanks for joining this session. We are really looking forward to all the submissions that have been made, and we are eager to hear more about your results you obtained. I also have an announcement for the weather station challenge. So we got some interesting submissions. However, we were not fully convinced on the quality for giving prizes. So therefore, we decided to rerun the challenge in the beginning of 2024, so beginning of next year. To invite you to continue to work on the project, because we found out that a lot of you didn't have enough time to submit the final results, and therefore we invite you to continue, and we will rerun the challenge beginning of next year. Thanks.
Thanks a lot, Jonah. So yeah, that's a very nice offer that we are going to give more time. We had multiple requests, especially on the lack of time. So we'd like to give some enough space. And of course, people who have been working on it for the past few months, you have a head start already. So you can continue working on those, and we are going to make an announcement on the new timeline and of course the prizes. So looking forward to more solutions in beginning of 2024. Okay, so right now I would like to just give a quick presentation, an overview of the challenge itself that we have run this year. It was quite short, and maybe that's why some people had problems to finish their work. I understand that more time was needed. So just a quick overview of the plant disease detection problem statement, as well as the wildlife monitoring problem statement. And so the overview, we started in August. We started curating in June until August, and we launched towards the third week of August. And somewhere in August, we also had the proposal submission. So teams were supposed to submit the proposal, and then the model checkpoint and final submission in November. And of course, we are today for the finale and awards. So congrats to all the teams who have made it this far. And of course, this could have not been successful without our partners who have worked tirelessly with us to help us to make this experience better, to make these problem statements possible. So I'd like to thank Edge Impasse. And of course, most of the solutions that you're going to see were developed on the Edge Impasse platform. So quite a big thanks to our partner, Edge Impasse. Seed Studio, they provide hardware to some of the teams. You will see some of the deployed solutions or some of the tinyML solutions were developed on Seed hardware, as well as Arduino. They also offered hardware. So some teams developed their solutions on Arduino. So after developing in Edge Impasse, they deploy in either Seed Studio hardware or on Arduino hardware. So thanks to all these partners. But of course, I would also like to mention the tinyML Foundation who have been helping us tirelessly to make sure that the problem statements or the competitions are successful. ICTP, our colleagues in ICTP, especially Marco Zenaro, who has been a big supporter of our activities. CSEM, who organized the Smart Weather Station, especially Jonah, who has been on the forefront running point from the CSEM side. Of course, ITU and AF would thank you to all the partners. As I already mentioned, we provided hardware support to some teams, especially from Seed Studio, as well as Arduino. Edge Impasse provided some prize sponsorship, but also the platform that most of the solutions were developed on. Some few highlights: we had 91 people enrolled, and from these 14 teams, they submitted their solution, and we had a total of 44 submissions from more than 20 countries, and we had sent out 12 hardware kits to some teams. And for today, for the two problem statements, we have a total cash prize of 2,000 Swiss franc, 500 for the first team, plus an Arduino tinyML kit that was sponsored by Arduino itself. And then the runner-up will receive 300 Swiss franc, the third will receive 200. And of course, some interesting certificates from ITU. And the overview of the session, We had the opening remarks, and this was the overview presentation. Now we are going into the third part, which is participants' presentation. So the teams are going to make a 10-minute pitch presentation, followed by a 5-minute Q&A. I would request our colleagues here. We have Jonah, we have Evgeny, we have Vishnu, to ask questions to the teams, to provide feedback to their solutions. And then the sequences, the first part will be on the wildlife monitoring and then the plant disease detection. After the presentations, we are going to have a award ceremony where we are going to show who is who and the ranking, and then we are going to close the session. Quite short and brief, but exciting and interesting presentations ahead. Okay, now I would like to go into the session itself. So let's go to the first team to present. The first team to present is going to be Underdogs. Are you ready to do the presentation?
Yes, 1 minute. I'll be sharing my screen now.
Yes, please.
Yeah, I hope the screen is visible.
Okay, yeah, you have 10 minutes to make your pitch. So good luck.
Oh, okay. Thank you, Thomas. So I'm Sudarshan, representing the team Underdogs. So this is our solution for tinyML competition track wildlife monitoring. Okay, so the crux of the problem is to develop a low-cost and low-power tinyML model, which has the ability to scale for diverse environments and wildlife species. So as of the hardware, initially we have planned to go for Mac 78000 hardware, but we couldn't get our hands on that. So when we looked into it, we came across this Seed Studio's Xiao ESP32S3 Sense model. And so we pivoted the whole methodology to the whole Xiao's ESP32S3 Sense model. And it has low memory consumption, so it suited our purpose, so we went with it. And also we made a 3D CAD model, and we made a 3D model design for the casing. So this is our 3D model design for the casing. This is a visual representation of our workflow. So we capture the image with the OB2640 camera sensor, and then we send it to Xiao ESP32 Sense microcontroller. And then we have our quantized model in the microcontroller, which will predict the bounding box and classify the wild animal. Okay, so this will be this is the final cost estimation of the whole project. So the Xiao ESP32S3 Sense model Sense device actually cost about $1,499. So in dollar terms, it is like $18. And totally it comes to $20. And the Indian price would be around 1,674. We will get into the properties of the hardware model in the following sections. So as of the data set, we have utilized the data set given by ITU team. And we use the data set for given by the ITU team, and it consisted of several types of wild animals. But we removed the unbalanced animals, and then we cleaned the data, and finally we got around 15 wild animals. Yeah, we have actually went with the two approaches. The initial approach is we just used the MobileNet V2 based model, and we got the better accuracy in the model, but we have trouble deploying the model. So that's why we went with the approach number 2. Yeah, so we have actually utilized the Edge Impulse SDK for this one. So we came across their FOMO model, which is faster object, more object, which suited our purpose. It has less than 1000 KB file size, and it for microcontroller, this model is very apt. And we only had the capacity to train 7 epochs, because there is a constraint on Edge Impulse account for single account, which we can train for 20 minutes, and we only can train for 4 GB of data. So we only took testing data from those initial data set, and we got around 66% precision. The F1 score of 50%, and you can see the quantized and unquantized properties of the model. And right now we have several constraints on the Edge Impulse model for the non-enterprise account. If we buy enterprise account, we have several opportunity to train more number of epochs and get more number of accuracy. And as of the device, these are the properties of the device. It has average consumption of around 154 milliampere per hour. So for powering up the device, we actually used 2 lithium batteries, which has the capacity to give 4,300 milliampere per hour, and it will last 15 to, then the tinyML model and the Sense Xiao ESP32 model will last around 15 to 16 hours. As of the result, and yeah, the model we trained for 7 epochs, and yeah, we got around 66% accuracy and the FN score of 50%. And one of the things we mainly want to point out is the Xiao ESP32 S3 model. It is around 21 cross 17.5 millimeter size. So it is very apt to scale according to different environment, and we can place it around different places. Yeah, that's it. These are the sample results. Thank you.
Okay, thank you so much. I would like, you can leave the presentation. I think we can go into the Q&A. So I would like to ask Jonah first, maybe if you have questions, comments.
Yes. Hello. Thank you for the interesting presentation. Yes, I have a few questions. So regarding the model, how many classes did you have in the model? How many animals could you differentiate?
We actually had around 15 classes. So initially there were like more than 30 classes, but there were some unbalanced data. So we collected some data annotated, and finally we got around 15 classes. And in the report, we gave what are the animals we actually went with. I didn't want to put that in the PPT as it will cover a lot of spaces. Yeah. And everything is one hot encoded. So in future, if you want to scale, we can just one hot code them the new data set, and we can train it on the edge impulse account. Yeah.
Okay, I see. And so the F1 score is the average across all the classes?
I'm sorry, can you come again?
The F1 score that you presented?
Yeah, it is average along all classes, yeah.
Over all the classes, okay. And what is the drop you got due to quantization? Because you mentioned like the model non-quantized and afterwards a quantized model.
Yeah, 1 minute. The accuracy drop, or the performance improvement?
The accuracy drop, yes.
Yes, from 66% it is reduced to 63% precision. F1 score is around 49, I guess, 49, 50, yeah.
Okay, I see. Okay. Okay, thank you.
Thank you.
Okay, thank you. Vishnu, have some questions?
Yeah, so Sudarshan, thank you very much. Just a quick question: the night capture, the camera is capable of night capture at all?
No, sir, no.
Oh, okay, thank you.
Okay. Any other questions?
Okay, I'm not sure if anyone else has some questions. We can also check from the chat, but I don't see more questions. So if anyone has some questions, you can also type on the video and we are going to take them. So in terms of the next steps, right, to improve your solution, if you have to be ambitious, what would be the next steps to improve your solution?
Okay. So right now we only train the whole model on the testing subset of the data set, which is not enough data set. And then also we might be collecting a lot of data set that with a diverse environment and a diverse species. And another thing is we only trained for 7 epochs because of the constraints of the edge impulse model. So in future we might be able to buy some enterprise account and go with training the whole data set. Yeah.
Hey, thank you so much. We appreciate for your presentation. Right now, we are going to go to the next team to present. So we have AI4D. Fatma, I guess you are the one who is going to make the presentation, so you can share your screen.
Okay.
Hey, you have 10 minutes to present. Good luck.
Thank you. Hello, everyone. I'm Fatma Isa, and I'm representing AI4D Research Lab. So, this presentation will talk about objectives. I mean, the outline will be the objective, problem statement, methodology, results and discussion, limitation, and futures, as well as conclusion. The objective of this challenge was to develop a teen machine learning model tool that can be capable to detect and classify wildlife, wild animals in different environments. That the tool should be with lower energy consumption as well as higher accuracy and performance. So to monitor the wild animals physically, it consumes a lot of time and it is costly. But machine learning have been utilized currently to perform that task, as well as teen machine learning approach have become with more promising outcomes. So we tend to use the teen machine learning approach so that to develop these tools of monitoring the wild animals. So in methodology, we undergo, at first we identify the data, where most of our data we have obtained them from open source, and most of our data were from Zindi. Then we undergo the data preprocessing, model training, model evaluation, and model development. But we use the two methods. At first, we use the traditional methods that use in Python codes, and then we use the edge inference model, technique to develop this model. So the first model, which is using the Python, we had the sample data set was 70,552, while with 10 classes, while the second model was with 10 classes, as well as the sample were 2,500. So in using the Python, actually we utilized the CNN model with Inception version 3. And doing that, we had to do hyperparameter tuning, as well as we use transfer learning. So transfer learning techniques, so that to have the efficiency of the model. And in Edge Impasse, we used the MobileNet version 1 and MobileNet version 2 models in developing the model. While in model deployment, we use the Arduino Nano, which we have obtained them from the Arduino company. So the results from the CNN model was quite. The results from CNN model, based on different classes, was like this, and the average weighted average for precision was 88%, while the F1 score was 8 for the weighted average, and the accuracy of the model was 77. It was 87. So from the Edge Impasse Studio, from the Edge Impasse model, so we used the MobileNet version 1. The F1 score for the version 1 was 87.5%, while the accuracy after the quantized was 84.21%. While the accuracy before the quantization was 83. So we lost almost 1%. And for the version 2, MobileNet version 2, the F1 score accuracy of the model was 96.3, while the accuracy after the quantized model was 89.28, and before the quantization, the accuracy was 92.27. So then the model from the edge inference, we try to check it on the live classification web API, and these are the results as they can see here, as well as when we tend to check them on the terminal, on the live terminal. So based on those models that we have used or we have developed, they showed quite some promising results compared to the other works that have been done by other researchers or scholars. For instance, the MobileNet version 2 was high with the performance compared to the model that developed by Richard Gotham, which were their model was with the F1 score of 67%. So our model showed the impressive results of the 92% of the accuracy. So in doing our works, we had limitations. So some of the limitation was the resources such as GPU and powerful computer to use, as well as the time constraint, where we intended to deploy. We intended to test our model or the device that we have come up with to the real life. To the real park, so that we can capture the wild animals and to allow the tool to perform the task that we intended to. But due to the time constraint, we didn't go for that. So we ended to do the live. We ended to do the web classification. The future works. Among of the future works that we hope to do is to use machine learning model, machine learning models by exploring real-time operation system, as well as to develop solutions that are not only low cost and low powerful, but also scalable and adaptable. So in conclusion, we can say that from our models, the model that have been performed so well was the MobileNet version 2, but we can't compare with the model that have been conducted using the Python, since they use different data sets. And this work honor researchers and conservationists who are doing more of their researches on wildlife. So through this work or through this result, it will help them to know more about the—
1 minute to finish.
Okay. It will help them to know more about the wildlife behaviors, as well as we expect technology to help and protect our natural worlds. Thank you.
Okay, thank you so much. We go to Q&A. Or is there a demo to be done?
Yes, Ipiana is going to do the demo.
Yeah, so you have 1 minute to finish. Please be quick. Yeah, we have to keep the time. Well, thank you very much. I'm going to present a demo. Okay. Oh. Fatma, can you stop sharing?
Okay.
Okay, Piano, go ahead.
All right, thank you. All right, this is just a simple demo of our device on which it will run on the web API. As I hope you see this live classification on Arduino Nano, right?
Yes.
Okay, yeah. So our model deployment has it can be done by using a web interface or using Edge Impulse Studio. And this now is running from the live classification from the Arduino Nano, the device that we are using and which we have deployed our model. And I have some few samples. We have used 8 classes, and I'm going just to point my camera straight to the one of a few these samples and see the live inference. For example, now I'm just targeting to an elephant. As you can see, it gives 0.9, 0.75, so it will keep going up and down. And here we have deer. The deer, as you can see, it is 0.99, almost 1 to be 100. We have a giraffe, but this time it's just a half image to see if it will just take the patterns from these giraffes. Okay, but okay, it just says this is uncertain, and it okay, now it's giraffe for 0.86. Then I have here the lion. The lion, yeah, it says 0.09. That's the live inference. We have the tiger. Okay. Yeah, 0.096. We have zebra with a person. So we want to see if it can differentiate between a person and a zebra. You see, it says zebra now 0.97. So this is the live inferences that are running from the device itself. And for the Edge Impulse itself, we were using this barcode here, of which now I have scanned on my phone, but again, I cannot share the screen from my phone to show the live inferences. But it ran again from the mobile phone. But I don't know, maybe I don't have the permission from the Zoom to be able to share the screen, because I've tried and it failed. Thank you very much.
Okay, thank you so much. So we are going to Q&A. Would like to ask some questions. So Jonah and Vishnu, please, the floor is yours.
Thank you very much for the interesting presentation. I have a few questions as well. So first of all, in your report, you mentioned MobileNet V1 and V2, and you say that V1 works better than V2. At least from the results, I see that the inference time for V1 is smaller than for the V2, which is a bit counterintuitive, given the fact that MobileNet V2 is more optimized regarding resource consumption than V1. So can you elaborate on this?
Yes, when we were doing these training, at first using Edge Impulse Studio, we used the normal way by custom labeling, and we used Make Sense AI to label all the data. And when it comes now to training, and we failed because the Edge Impulse offers only 20 minutes for execution on training. So after that, we changed the approach. We shifted to use the transfer learning. of which we changed even the way on how we label our data set. We use one label for all, one label per image. And now we start using the mobile version 1, mobile version 2 with different dimensions like 160 by 160 size of image and 96 to 96. So when we used mobile version 2, it was generating around 72,000 features, of which now when we train the model and become to deploy, it ends up with a large peak RAM memory. The last training was 301 KB, of which now it is too high for the Arduino Nano BL license, which supports only 254. After we tried to change some parameters, it was giving us 254, 253 KBs, of which now the microcontroller failed to allocate the enough memory, stack memory to accommodate the size of the RAM. Now we shifted to version 1. The version 1 provided the good results. We had the first one, which gave us, with few data, it gave us the RAM size of 33 KB. Then we said, no, these are very few data. So we just added more data and trained once again. That's why we end up getting the 124 KB for RAM, and we deployed, and it was showing the good inferences. While in the first, it was saying failed to allocate the tensor arena. That's when we checked on Edge-Impulse forum, they said, no, this is related to memory. Maybe you have the oversized memory that can be accommodated by the microcontroller. So for our results, I think the presenter made a minor mistake. The version 1, MobileNet version 1, is the one which gave us the best results, and it is the one that we have deployed in our device.
Okay, and do you also have an explanation for Edge-Impulse why the inference time with the V2 is much larger than the V1?
Yes, the V2 was giving us very good performance, outstanding performance, 97.5, 94.7, 97.3. But when it comes now to the deployment, the on-device expected performance was too high. Even if we tried to perform EON tuner and select the best model, still it was very high when it comes to RAM consumption. So we didn't opt for version 2. We opted for version 1. I don't know if I've answered the question.
Okay. And then I have one other question on the F1 score. You showed a table in the presentation where the average F1 is around 80%. But then I also see some classes that have a much lower, F1 score, around 24%, or 30, around 30, 40. So what do you think could be done to improve these lower F1 scores?
Okay, thank you very much. I think because most of this data we just collected from the secondary source, internet, from Kaggle, from Google, and other people who have now done the research. So we just taken their images, cleaned, and now they can vary in terms of size, even the weight. And sometimes in the other round, we tried even to force them to be square, reduce the size of images to be not even more than 100 KB, so that we can have more images. But still, because these images are secondary and some have very low resolution, which now when you are training the model, they'll end up giving some a few, when the machine now is trying to train, sometimes it can even, you can just see by our naked eye that the image is clear, but the machine can fail even to understand. So I think in order to improve these low F1 scores, is to change these training, to try more on these neural network settings, but again, to have the good data sets of which now they can improve or boost up at least the F1 score above 80 and above. Thank you.
Okay, thank you.
All right.
One last question, maybe Vishnu, from your side.
Yeah, thank you very much for the nice presentation. I just want to ask about fine-tuning use of resources, GPU resources. In your limitation, you have mentioned it already. What would you do with the GPU and powerful computer? What are the steps, please?
Okay, it was among of the limitations that because we had two approaches when we were working on this challenge. The first approach we were using Python, and the second one we were using the Edge Impulse, which is a web-based solution. And the good thing about Edge Impulse, they provide the GPUs, even though it is limited for just developer mode. But for the normal, for the custom, by using Python, at some points we failed even to compile because it was consuming too much amount of memory. That is why at the end we invested all our energy to work on Edge Impulse to find the easiest way on how we can get the high performance mode by using these GPUs online. I don't know if I've answered the question. Thank you.
It's clear. Thank you very much.
Okay, thank you so much. So right now we are going to the third presentation in the wildlife monitoring. We have ADN innovators. Abe, the floor is yours. You have 10 minutes for your pitch. Good luck.
Yes, sir. I'll be presenting. So good evening, everyone. The topic of the presentation is the scalable and robust wildlife solution by tinyML. Our device is Prani, and we are a team of electronics and telecommunication engineers with interest in AI, ML, and this has been quite in our domain and an interesting experience to develop a project at such a large scale and for such a huge audience. As the problem statement has successfully conveyed to us that the tinyML model has to be accurate, it has to be energy efficient and compatible, reducing the latency for a precise result. I believe we were quite fortunate to achieve the following results with our project. Along with this, the problem statement also had an emphasis on developing a solution, inculcating a holistic approach to the entire environment and its surroundings. So for the same, we have had developed various applications and combined the entire architecture to present a very holistic approach to the solution. So now, dividing our entire device into 4 sections. First, we have our ML model. For our machine learning, we basically utilize Edge Impulse, and as it provides a great platform to model to test our results and to deploy it on various platforms. So yeah, as Edge Impulse utilizes TensorFlow Lite for training its models, we used the MobileNet V2 as it was highly scalable. It gave us models for various devices, and our accuracy was achieved of around 83% for training and 71% for testing with 8 classes. Coming to the data set, we had a total of around 2,619 images with average of around 272 images per classes. On the data set side, we realized that the more the quality of data set increases, the better we get an output. As when increasing the classes, we need to increase the average images per class as well. Coming to the mobile application, we have developed a Flutter-based mobile application, which is currently only for Android users because that's what was feasible for us. And the features in our application are quite varying, uh, quite holistic, coming with authentication, user-based authentication, which will provide protection to anyone accessing the application. So we kept in mind about the protection of wildlife, how the authorities need to only have access to all these uh, tracking and pattern management of species in an environment. Then comes the real-time database, the classification results, the detected species had to be accessed in real time. And then comes the mapping part of it. They had to be located, the vicinity of the species had to be located in a quick and efficient manner, so, and to be able to track and locate them. And of course, security and accessibility is our major viewpoint. Coming to APIs, we have used a variety of APIs, starting with authentication and RTDB from Google Firebase API integration, then which we have used successfully by integrating with our embedded structure and application as well. Coming to maps, we have used Bing Maps. It presents us as a free and accessible solution, and which was highly scalable and also deployable in a robust environment. So, statistics. Coming to statistics, we have had achieved around a time span of 20 to 40 seconds for the entire process, starting with the classification of a species, and then coming to the application front end, where a user can view what species has been classified, the timestamp, at what particular vicinity or area it has been located. It gives you a tracking point as well. So over here right now, I'll just like to present my application and a quick demo. So I'll just share my screen from a different device. Yes. So as we are able to see, I have a Flutter-based mobile application wherein if I just type my authentication, user ID and passwords, so it has a feature which kind of blocks any malicious practices or anyone else by entering a secured interface. Yes, so now as you can see, I have my device that I've connected right now over here, and this has been listed as a single device. You have the recognized species, you have the timestamp, you have the day, and you have the particulate matter present in the surrounding. If I click on the maps front, you will be able to locate an interactive map which is scalable. Currently, it has been adjusted to National Park in Mumbai, and like you can have it scale to any environment, any application, and it will give you outstanding results. So now coming back to my original screen, let me just show you a quick demo, quick example. Over here, I have my real-time database, and what I was just showing, these were these animals. And if I show my device, to this, it will recognize it quite quickly, and we will be able to see it in real time right at this place. So as you can see, it has recognized lion in this scenario. And let me just go back to my presentation now. So yeah, this all took around 20 to 40 seconds to recognize my species, give it up on my application, track my species, and I think this has a huge potential to be highly scalable and be a cross-platform application. We have developed our CAD models because we need a protected device. We are still working on a closed structure. We are in an open structure environment, and we'll surely have a closed structure environment very soon. And the model's accuracy, we have a testing accuracy of 70%. This can be increased if we have a sufficient data set in the near future, and surely we are working on that as well. The applications that we can think of currently are obviously protecting of wildlife species, obviously tracking them. Then it can also be domesticated. It can also have a different approach, taking into on other species, other classes of the fauna, such as birds, such as oceanic animals, insects, and everything. So those views we are kind of looking into. And currently, that's all from my side. Thank you so much.
Thank you so much for the presentation. Right now, we are going to go to Q&A. So Jonah and Vishnu, the floor is yours.
Yay. Can you see me? Can you hear me?
Yes, sir.
Okay,
yes, sir.
Great. So thanks a lot for the presentation. So yes, I have a couple of questions. So the first question I have is, so you're using a data set that exists today. So do you know something about the distribution? Do you have class imbalance? How did you solve these elements?
So the data set that I acquired was currently available online. So that those are the resources that I had to go those as well. So distribution and so another thing that you said was distribution and
yeah, the class imbalance. Were the classes balanced across the data set, or did you have much more lions than leopards? Or
so there was a discrepancy of the minimum images per class was around 250, and the maximum was around 300. So 50 images discrepancy was there, and I think so that's why it resulted in some classes getting classified at a much accurate rate, and some classes being classified at a less accurate rate. To increase that, obviously, I will have to make my data set more efficient and scale it to a larger level, so that images per class, the distribution per class becomes equal, and that's how I'll achieve a greater result. Yes.
Okay. And then I also read in your report that you also have a connection with ChatGPT. Is that correct?
Sir, currently that connection with ChatGPT was we had taken the accessible element of the ChatGPT with us, but that wasn't quite applicable. I mean, in our demo, currently right now, we were going to use that. We have that code with us right now, but to show it in our demo, it will glitch, and something in our presentation won't suffice. It doesn't show the screens properly right now in our mobile application. So something I'll have to look into that. Yes.
Okay. And do you have can you give some information about the battery lifetime that your device would have?
So sorry, I had a network issue.
Can you say something about the battery lifetime that your device will have?
Yes, sir. Sir, battery currently we tested out with a lithium-ion battery, a 3-volt lithium battery, and while using the battery, we tested it out that for an extensive use of continuous usage, it will last about 2 or uh, 3 to 4 days, I think so, for a continuous usage. But what we are going to do is we are actually implementing, like we have used ESP32S3 by Seed Studio, and they give a sleep status as wherein we can put the device on sleep, which will save us quite a lot of power. And like for example, at night we cannot detect anything. So for those periods of the day, we can put that device on sleep, and that we can extend the power to quite a week or so. And so that that way the device could be even more scalable. Yeah.
And do you also have a solution in mind to also be able to detect animals during the night?
Yes, sir. We thought of going for an infrared camera, and like we went out and saw a few of the solutions. So the infrared camera, like the only issue at hand, or the only problem at hand that we have to solve, which will be a great achievement, would be uh, to uh, get to classify the images which are, I suppose, uh, uh, mapping the heat signatures of a species. So to get to identify how a particular species has its heat signatures being displayed on the camera. So that was the only approach that we kind of thought of. And I think so if we build on to that, I believe we'll be able to achieve that as well. Yes.
Okay, thank you.
Yeah, bye. Thank you very much. Nice presentation. I just want to ask about your training and quantization steps. So did you do any fine tuning quantization training steps at all?
Yes, sir. So the final model that was deployed was around, it was indeed quantified, uh, because that's what gave us a lesser RAM usage, and a lesser RAM usage will definitely mean that the device won't be overheating, or the battery life will be prolonging. Apart from that, the services were basically all that iGempulse provided, and we adjusted that to find the best possible deployable model.
Did you also hit this 20 minutes limitation? 20 minutes limitation that the other participants were talking about, please.
20-minute limitation. I am not getting you, sir.
There was some limitation with the free offer from iGempulse when compared to the enterprise offer. That is what I was asking.
Yes, sir. Yeah. So the 20-minute limitation about training the model. Sir, the that limitation, we kind of were thinking that we may hit that, but I don't think that happened, because we had quite a convenient data set, and so the training time wasn't so drastic. We used V2, which gave us a very huge variety of devices to be deployed, and the training time did not go to the maximum limit. It was well within. I believe it took something around 5 to 10 minutes. That's all. It did not go anything beyond that.
Interesting. I believe that is different from what others were saying. Yeah, thank you very much.
Okay, thanks a lot. Right now, we are going to the next part, which is plant disease detection. So we have two presentations. The first one is from tinyML. So yeah, Mohan, the floor is yours.
Yeah, I'll just share my screen.
Okay.
Yeah, is my screen visible?
Yes, please go ahead. You have 10 minutes. Good luck.
Okay. So greetings to everyone present here. I'm thrilled to be part of the AI for Good Challenge. Thanks to International Telecommunication Union. Myself, Purushothaman, from the team tinyML. I'll be presenting a solution for the scalable and high-performance tinyML solutions for the plant disease detection. Just a brief introduction about my team members. I'm a pre-final year undergraduate from Indian Institute of Technology, Madras, doing an electronics and data science dual degree. And Mr. Mohanasundaram SP, he's an independent researcher based off Bangalore from India. And Dr. Ramaswamy is, he's a professor in the Department of Electronics and Computer Science Department from King Faisal University, Saudi Arabia. You can have a glance at the agenda. So just to give you a prelude on what motivated us to participate in this event, coming to the statistics part of the global crop loss, firstly, the Food Agriculture Organization of the United Nations estimates that annually up to 40% loss of crop yield is due to pests and diseases, which nearly accounts for $225 billion. And the second one is that during the tinyML Talks 2022, Pete Warden, he's the founder of Useful Sensor Company. He demonstrated his sensor, which is named as person sensor. It basically gives the push and post and identity of the person. So by building upon this, our main idea revolves around in providing ML capabilities, machine learning capabilities into a sensor for the crop disease detection, where the end consumer should require no coding knowledge. So this is where tiny machine learning comes into play. It's an interdisciplinary paradigm which enables machine learning applications to be embedded into, to be deployed into embedded systems, which are cheap, power and resource constrained devices, typically operate in the milliwatt ranges. With the advent of advanced technologies in agriculture 4.2, embedded machine learning finds a great use case in our context. In agriculture, the threat of crop diseases is a constant challenge that farmers face. Early detection and precise intervention are crucial to safeguard crops and ensuring the food security. Our main focus is on crop monitoring and management, basically disease detection, where tiny machine learning enables to perform disease detection by analyzing these various patterns and anomalies associated with the crop images. As I mentioned, we plan to create the smart crop sensors, which basically detects the objects, in our case, the crop, and classifies the disease classes once the crop is captured based on the inferencing. So how do we manage to do so? We used Edge Impulse to build our data set, to train the algorithms to do data engineering and feature extraction. And these models can be fit right into these edge devices, tiny MCUs or handheld devices. If you look at this flow diagram, we provide the training images along with the labels during the model training, and these trained model are deployed into embedded hardware devices and can detect this performs the classification and detection via the pre-trained model. So the farmer might not have access to embedded hardware, but everyone has access to mobile devices. So he can just capture and picture and send it to the, he can access the pre-trained model. And based on the algorithm, we can fetch the results of various crop diseases. So the dataset which we use is Plant Village. You can access it through the provided link. It has around 60,000 images. It consists of 13 crops which are distributed among 38 categories, and along with the random leaf images, background images, along with the noise. And here you can see the test and the training split and the cleaned data set. Coming to our results, we have used an architecture, MobileNet version 1 architecture, where the image size was 96 cross 96. These are obtained results for specific crops, 4 crops, along with the performance benchmarks and the accuracy and the confusion matrix. It includes with and without the Eon tuner. Basically, the Eon tuner selects the optimal model for the target device, which we are training with. The target device was Arduino Nano 33B license, which operates on Cortex M4 processor running at 64 megahertz clock speed. As you can see, we have obtained an 91.1 accuracy and a loss of 0.32. And these F1 metrics can give you information on the accuracy, precision, recall, etc. You can see that with the Eon Turner, the accuracy is has an average of 92 to 94, and the RAM and the ROM allocations are much suitable for the embedded hardware. And the accuracy is slightly better without the Eon Tuner. So yeah, for further details, you can visit the GitHub repository provided here. Now I'll be showing you a quick demo where I'll show you some of the live testing results and then video for a healthy and disease infected one. And the demonstration is done using the 33B license along with the OV7576 camera module. You can see here. This is for the corn. This is just a snapshot. As you can see, we have tested using the corn image. This is a northern leaf blight. The image we provided is northern leaf blight, and the OV7675 inferences the object, which is the crop, and we received a confidence threshold of 0.98. So the model is 98% sure that the predicted image is the northern leaf blight. You can also verify it using the clustering provided here. If you can see the blue blob around this area, it is highly correlated with the northern leaf blight and also the Cercospora leaf spot. So our model is much robust to diseases. This is in the case of disease-infected crop. Now I'll show you in video where I've tested using the grape leaf. Now we'll connect the Nano 33B license using the Web USB mode. After connecting it to using the Web USB, we'll get a MAC ID here, and the camera feed can be monitored through here. This is the image that I'm providing to it. This is a grape plant which is healthy, and after doing classification, we'll get the result as. So yeah, this is a classification result. You can see that it has predicted that the crop is 99% and healthy class. And if you can see in the image, there's an decoloration in the top part of the leaf. So it gives a probability of 0.01 for the black rot classification. You can also see the clustering of that. So this is in case of a healthy crop, and we get a confidence level of 99.99. And coming to the conclusions, the unique selling point of our work is that we devised a crop disease model using tiny machine learning with an average accuracy of 92%. And these models fits into tiny microcontroller units of approximately 256 KB RAM size or lesser. And it requires minimal power requirement, approx 50 milliwatts, and it can be easily scaled up in large scale farming. So for example, this pre-trained model, which is deployed in the embedded hardware, can be used along with the drones, and these can be monitored for large scale farming. So with the right early detection of crop disease, we get much benefits such as ease of use, scalability, informed decision making, and sustainability. And to conclude, our future directions are that we aim to scale up our project by devising a smart crop sensor, which is inspired by the person sensor board from usual sensors, and which it prompts out the various classes of disease based on inferencing. And also a robust state of the art architectures can be developed, where in our case, we have used a single project for a single crop. We can use some high-level complex architecture so that multiple classes of images can be used for complex segmentation. Yeah, thank you.
Okay, thanks so much. So now we're going to Q&A. So Vishnu and Jonah, please, the floor is yours.
Vishnu, go ahead.
Thank you very much. Yeah, that's just a very nice presentation, Purushottam. I want to ask about your last part, that is updating. How can you identify some steps where I want to now retrain and update the model, please?
You can do like model testing and versioning in the Edge Impulse platform. You can do retraining of the model. The video which I showed, I used a grape plant, healthy grape specimen, and based on the pre-trained model, I get the classification which has a threshold of a confidence threshold of 0.99, which is basically I given a healthy input. The model predicts it as healthy.
I see. Okay, can I update the data set with new values?
Yeah, you can update the data set. We have also used random backgrounds along with the noise added images. So we can bring in non-linearity into our convolution models so that it can adapt to more real-time data sets. So for example, the farmer might use these handheld devices, which are mobile devices, and use these models, right? So they don't know the field of view. They can't capture proper images. So by bringing in random images, we can improve the accuracy.
Okay. And what about lighting? Did you face any problems with lighting in the images?
Not much actually. The data set is like has an data augmented version of Gaussian blur gamma injection. So we didn't face much issues.
Especially with that, you showed that discoloration at the background, I mean, at the edges of the leaf, right? So
Yeah.
how do you?
As per the result is concerned, due to some slight discoloration, I got an accuracy probability of 0.01. So I can still improve it by maybe like crop the images and giving proper inputs to the image data.
Did you face any problem with availability of labels at all, or the label
No.
data at all?
No, we haven't.
All right.
Okay, thank you so much. Let's go to the last presentation. So we are going to the team Underdogs for the presentation. The floor is yours.
Yeah, is the screen visible?
You have 10 minutes. Good luck.
Okay, so yeah, I'm Sudarshan again, representing the team Underdogs. And is it okay if I just skip the hardware introduction section because it is same as the previous presentation?
Yes.
Okay. So the crux of the problem statement is once again developing a low cost and low power tinyML solution for plant disease detection, which can be scaled for various environments and plant type. Yeah, so like I mentioned before, I used a Xiao ESP32S3 Sense device. And these are the 3D casing. We accommodated the 3D tracing from the previous project. This is the model flow, which is similar to the previous one, except we don't have a bounding box here, just simple classification. And yeah, the cost estimation is same as the previous one. And the data set is different. Data set, we have used the one given by ITU. And the data set, there was some undersampled data set and the data set given by the ITU. So we actually removed a few of them. And there were totally 70,000 images for training section and 17,000 images for testing one. And those data set were previously augmented. So we just went with the tested data in order to cooperate with the constraints from the Edge Impulse side. And yeah, like the previous one, we actually went with the two approaches. One is MobileNet V2. So when we trained the MobileNet V2, we got around 98.9% categorical accuracy, and the labels were one hot encoded. And number of epoch we trained is 31. So it is after introducing cosine and the linear scheduling purpose, and early stopping, we stopped at 31 epochs. We faced the deployment challenges because the model went around like 9 MB sort of, but the size of the model, acceptable size for the MCU is around 8 MB. So we just switched to another model. So this model we developed using Edge Impulse. So it is just 32 3 blocks of CNN, first one with 32 filters with a kernel size of 3, followed by 2 16 filter CNN layers with the kernel size of 3. And in future, we can scale it up as it required. So this takes around like 363.3 kilobytes of RAM after quantization. So we only able to train up to 7 epochs due to the constraint, and we got around 74% categorical accuracy. And yeah, this is the power consumption as I mentioned before. So we actually tried incorporating solar. This is a rechargeable lithium-ion battery. So we tried to incorporating solar power, but it was able to only power up one lithium-ion battery. So we failed. But in future, we will be incorporating much bigger solar panel. And yeah, so like I mentioned before, the Zio ESP32 is very small. It is very compact, and yeah. So if we want to deploy it on a drone for surveillance purpose, we can easily mount it on any devices and use it for surveillance. And these are the results. And these are the results from the Edge Impulse. I hope it is visible, or else you can find the same copy of the matrix in our report. Yeah, thank you.
Hey, thank you so much. Questions, Jonah, Vishnu, the floor is yours.
Thank you for the nice presentation. Something I was wondering is in your in the 2 works that you submitted, you exactly have the same energy consumption, and this looks strange to me because the model is not exactly the same. Hence, the energy consumption should be different. Or am I wrong?
Yeah, actually, the kilobytes of the model energy consumption is very similar. So we went with the approximate values. And the processing is also same, actually. That's why.
Okay, so basically you didn't do custom tests with for both problem statements, but you made the estimation and used it for both.
Yeah, exactly. Yeah.
Yeah. Okay.
If you looked at the previous one, the lithium-ion battery was able to withhold like for 15 hours. Here it was like 16 to 17 hours.
Okay, I see. And for the other submission, I saw you also included the video. Here I didn't see a video. Can you also show a demo, or is this not ready today?
No, the demo is not ready today.
Okay, thank you.
But it is incorporated in our report.
Okay.
Yeah.
Yeah, thank you, Sudarshan. Just a quick question.
Yeah.
Did you here also face the same limitation with Edge Impulse epochs and time, or that was not a problem in this problem statement?
Yeah, we faced the limitation with the Edge Impulse here also, but there is an option to retrain the same model. So by the second retraining, we were able to get better accuracy, but with third retraining, it actually decreased. So yeah.
Interesting. Why didn't you use the same approach previously, or this doesn't work every time? Or what's the feedback on this approach at all?
Okay, the previous model, when we retrained the same model, the accuracy deteriorated. So that's why we didn't use that model. So we only stick with the first model. Yeah.
What about the data imbalance? This data set was
not
well
that much
balanced?
heavily imbalanced, and yeah, only 2 to 3 classes were heavily imbalanced. Rest of the things are around the same sizes. Yeah, so we didn't face that much problem with the data imbalance issue here.
The balance between accuracy and efficiency, what does that mean actually? So you say that you struck a balance between accuracy and efficiency. What does that mean?
Yeah, okay. So the model is very simple. So it is like 2 or 3 layers of CNN. Before that, we actually trained for 5 layers, but we are only able to train for 3 to 4 epochs, but we are able to get better accuracy. But when deploying, it left a lot of memory footprints. So it takes around a lot of RAM usages. So we want to reduce that as much as possible. and just give maintain the same level of accuracy. We lost like 2 to 3% of accuracy there, but we were able to get around like similar accuracy with the model with the fuel parameters. Yeah.
I see. Okay, thank you.
Okay.
Jonah, any questions from your side?
Sorry, and I already asked some questions, so for me it's all good.
Okay, thanks a lot. Thanks a lot. We appreciate. So now we have finished presentations from the teams. And of course, after we finish all team presentations, everyone knows it's the time that we have been waiting for. This is the time where we are going to give some awards. Okay, let me share my screen just a little bit. Okay, so as you can see from the program, I would like to thank all the teams that have made quite good presentation and demos. We have like video demos demonstrating the live application, a phone application as well for the solution, so quite nice. And of course, we have to award everyone who is deserving, but of course, for all teams that have reached this far, congratulations for making it to the finale. You have done quite a wonderful job. Evgeny, do you want to announce the winners? I can show the certificates on the screen and you can read out the names if you are available. Okay. In that case, I will start the announcement. So everyone just bear with me. I have to change the screen share. Oh, yep. It's the wildlife monitoring team that won. Okay, let's get started. Yep. Here we go. So right now we are starting with the wildlife monitoring program statement for the tinyML challenge. And the third place team will receive 200 Swiss franc. And thank you so much. Congratulations for all your hard work. And the third team will be Underdogs. So congratulations to Underdogs for being ranked third. Next, we are going to the second best team. The runner-up for this program statement is receiving 300 Swiss franc, and the runner-up for the wildlife monitoring program statement is going to 80 innovators. Congratulations. And for the first winner, for the first is AI for D-Lab, so they win 500 Swiss francs. So it's another family of people who congratulations to AI for D-Lab for winning. Up next is the plant disease. Up next is the plant disease detection. And for this one, we had two teams that was listed for the finale. So for the second position, 300 Swiss franc, we have Underdogs. And for the winner, for the 500 Swiss franc, we have tinyML. They receive 500 Swiss franc plus a tinyML kit. So congratulations to all the winners. Thanks for being part of the competition. We wish you all the best. And before I finish, I would like maybe to ask a few words from Jonah, from Vishnu, and from Evgeny. So Jonah, you can go first for a few words to the winners.
So yeah, first of all, congratulations for the nice prizes that you won. It was not easy to do the ranking. All the submissions were good, and I hope you will enjoy the prize. And I also hope you continue to contribute to the tinyML challenges, and feel free to attend also the challenge next year on the Smart Weather Station. Thank you.
Thank you very much. Yes, I congratulations to all the winners. The real winner is part of the community. So I would like to echo what Jonas told just now, that you please take it to the next level. That is, be part of the community of tinyML. Evgeny always says this, that there is a community behind this effort. Please be part of next year's roundtables, webinars, data set collection, problem statements. That's the real point. Models, accuracy, well, yeah, that is true, but there is a community behind this. Be part of the community, and let's grow together. Thank you.
Thank you so much. I would like to request if Evgeny can unmute, if possible. I understand it's too early in San Francisco, in California, so. Okay, in that case, I would like to congratulate everyone for all the hard work. And we understand there's so much work that went into this. It's not only designing or developing or training a machine learning model, but it's also making sure that your model is fit to be deployed in an embedded system, for example, in an Arduino hardware or in a Seed Studio hardware, and of course, making it work. And of course, some people have also developed a live application, a mobile application. That is a lot of work. So congratulations for all of you. And we hope you will join to more of the tinyML competitions that are coming up next year. As we are starting in January with the Smart Weather Station, you can start already working on it, and we will see you in the next time. So from me, I would like to wish you all the best. Good luck, congratulations, and hope we can connect in some other way. And of course, all these reports are available. You have the slides, the code and reports on our GitHub repository. You can check AI 5G challenge GitHub, and you find all the repository for the tinyML competition. So thank you, everyone, and have a good day. Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.